All right, here we go. Section 2.1, relations and functions. Let's do this. Okay. So, first off, we should figure out what a relation is. And a relation is a mapping of input values to output values. So what you put into something, I don't want to use the word function because not all relations are functions, but what you put into an equation or an expression and what you get out of that. Okay? Now, a relation has two crucial parts to it. And I know you're going to groan as soon as I show you what those two crucial parts are, because you're going to be mad at me for bringing them up again. Okay? A relation has a domain and it has a range. Okay? So the domain is everything that goes into a function. Typically, when we're dealing with a function of x, like let's say f of x equals 3x plus 7, the domain would be the x's, what you put into the function. Okay? The domain is whatever the variable is of your relation. Then we have the range. The range is what happens, the values you get out, coming out of our conjunction, junction, what's your function. And those can be different. Sometimes it's all real numbers, sometimes it's a specific set of numbers, sometimes it's just a little teeny tiny range of numbers. Okay? Or, I don't want to say range and range, but yeah. Okay? So you've got that. Now, when you get to be writing, and we'll be writing domains and ranges today and in this unit, when you get into the writing aspect of it, you don't have to repeat any numbers. Okay? So if in your domain, let's say there should be 2 5s, okay? You only have to write it down once. You don't have to write it down twice. In both domain and range. You only have to write any particular element of those once. Okay? These are also, draw your attention to this little teeny tiny word right there. Those are also sets. So they need to be in set notation. Okay? Now, set notation is the Alfred Hitchcock, is what I like to call it, of the English grammatical, what do we call these things? Not emojis. Typing world. I don't know. Now, if you're like me, you probably can do one of those two, but your other one looks goofy. Okay? And it happens, because that's me. So because it's me, I will also allow you to just do this. Ready? Here's how I will be doing it from now on. And I'm okay with that. I just don't want brackets, and I don't want brackets. Okay. There are 4 ways to represent a relation. Again, remember, a relationship is a relation is a mapping or pairing of inputs to outputs. Okay? 4 different ways to represent said relation. So, the first way is you can just write it as ordered pairs, or this could also be in here an equation. So that can also be an equation as your first way of writing your relation. Okay? For all 4 of these, I'm going to use those 4 points, those 4 ordered pair points. Just so you know. Okay? So that's the first way. Okay? In the ordered pair, it would, remember, as an ordered pair, it's always x comma y, left to right, or input comma output, or domain comma range. That's the first way of representing a relation. Second way is you can make a table out of those. So the points 4 comma 2 would have an x value of 4, a y value of 2. Same one. 3 comma negative 1, 1 comma 5, 4 comma negative 1. Again, x on one side, y on the other, usually left and right. Domain and range, left and right. Input and output. Here's where the real drone is going to come. Third way is you can put that relation on a graph. Now, this is crucial. If it's an equation, you connect. If it's not an equation, this is just 4 points. You do not connect them. If your relation is just points, you need to leave it as just points. If your relation is an equation, then you can connect them with a line, a v, a curve, a parabola, a circle, a square, whatever you have. But if it's not an equation, you do not connect. Okay? And the last one is one that I don't know if you have necessarily seen very much of. You probably saw it way back when you were in your pre-algebra, algebra type classes, and that's called a mapping. And a mapping has all of your inputs in one circle. It has all of your outputs in another circle, or all of your domain in one circle, all of your range in another circle, and then it's got arrows being drawn to connect them. So for instance, 4 comma 2 was our original point. Right now, let me go to a different color. 4 comma 2 was our original point right here. That, in terms of a mapping, would be this one right there. So you still have everything. It's just a different way of it. Okay? Let's get into something. Okay? So here's a new relation. I want us to find the domain and the range of that relation, and then I would like us to draw a mapping of that relation. Okay? Give you a second here to write this down. So my domain is going to be my x values, right? The x part of each point. So that's going to be a 2, a 5, a -3, and an 8. Agree? Okay. Now, you don't have to write them in numerical order, but it's nice for me if you do. Okay? So the domain here would be squiggle, -3, 2, 5, 8. Agree with that? Range is going to be the y values. -1, 7, 4, and 7. So my range then would be squiggle, -1, 4, and 7. And I don't write the second 7 because we don't have to. Agree with that? Then it said draw a mapping. So I take all of my elements of my domain and I put them in a box or a circle or an oval, and then I take all of the elements of my range and I put them in a box, a circle, or an oval. And then I draw arrows between those parts. So 2 goes to -1. 5 goes with 7. -3 goes with 4. And 8 goes with 7. And that is my map. Questions, comments, concerns, clarifications on that funky mapping? Okay. A function, then, is a special kind of a relation for which each input has exactly one output. Or each element of the domain is assigned exactly one element of the range if you want to get all funky math. If you want to get all regular old math for the peoples, we don't have any repeated numbers in our domain. Okay? Our domain is as many distinct numbers as there are for that particular relation. Okay? So let's play the classic game, function, not a function. Okay? Is this relation 3, 2, -1, 0, 2, -1, 4, 2? Is that relation a function? Yes? Yes? Yeah. We're looking at the x values here. So I look here, 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 and here. Are any of those the same number? No. Since they're not the same number, there's no repeated things in the domain. So yeah, baby, this is a function. What about letter B? Function, not a function. Why not? There's two negative ones. There's one negative one there, and there's one negative one there. So, not on our watch. That's not a function. Okay. So you can use that no repeated x values when you have the ordered pair form of a relation, when you have a table, or when you have a mapping. Okay? So like if we go back to the mappings of this one, this would be a function because there's never more than one arrow coming out of the same element from the domain. Over here, this would not be a function because there's two coming out of the four, two arrows. Okay? So we can use that for those. But there's also something that we have in our tool belt, and something wonderful. And does anybody remember what we can do if we have a picture, the graph? Vertical line test. The vertical line test says that if and only if we've got a picture, we've got the graph, we can take our wonderful, I want a line, I know I have a vertical line. We take our vertical line, and our vertical line we can find in many different things. You have probably 20 vertical lines at your disposal right now. Everybody's sitting around. Give me one example of a vertical line you could use. Everybody's holding one right now. Pencil. Pencil can be used as a vertical line. Give me another one. Paper. Yep, you can fold your paper over, right? And you can make a vertical line on it, or use a second sheet of paper. Another one. ID card. Another one. Your phone. It's your phone. Another one. Another one. Your hand. You can use your hand and be close enough to a vertical line, right? Okay. So you got lots and lots of choices. Everybody's got a vertical line at all times. Okay. What we do with that is we take that vertical line and we slide it across our graph. And if our graph, which is our graph is always in blue on this page, if our graph only ever touches our vertical line, it's a function. So this one right here is a function. This one over here is a function. This one over here is not a function because it touches 1, 2, 3, 4, 5, 6 times, and it can only touch once. So function, function, not a function. Conjunction. What's your function? Functions can be evaluated for any value of x, okay? Meaning if f of x, so this is, remember, this is not fx, the TV show, or the abbreviation for special effects. Okay? This is read f of x. Okay? So if we define our function as f of x equals 3x minus 4, and we want to know what f of negative 2 is, well, I am saying that I want to plug -2 into my function. And I want to get out the value. Okay? So my function is 3x minus 4. So I would plug -2 into that function. 3 times -2 is -6 minus 4 is -10. So f of -2 is -10. Hmm? You find me h of 4. Find me h of 4 and j of 2. And this would be 2 times 4. And I want to put 4 into x. 2 times 4 is 8. 8 plus 6 is 14. So h of 4 here would equal 14. J of 2, and that's going to be 3 times 2 squared plus 6 times 2 minus 5. 2 squared is 4. 4 times 3 is 12. 12 plus 12 is 24. 24 minus 5 is 19. So J of 2 would be 19. Questions, comments, concerns, clarification? Okay. Purple worksheet this week. The nice part is there are 0 questions on the purple worksheet, I believe, from today. Look at that. There are 0 questions from today on the purple worksheet. So you don't have homework until Wednesday. Your